All right. Thank you very much, Salim, for joining. Let me start asking straight, right? So, you have said somewhere that we are living through the most important decade of the human history. So, can you please explain why?
So there are two things happening in technology that we have never seen before, and I
Okay.
think it's worth just touching on those two things because it forms the foundation of what's happening at a broader scale, right? So the first thing is that we've seen Moore's law for 60 years, right? Double every 18 months. Well, we now have a dozen technologies that are operating on a doubling pattern. And we've just never seen this in human history. Throughout history, maybe one technology is accelerating or another. We've never seen this many all move at the same time. For example, drones are doubling every 9 months in their price performance. Solar energy every 22 months. And it's been doing that for 40 years. In neuroscience, the resolution at which we can image the brain is doubling every year. So fact one is we have all of these technologies on an accelerated path. So that's the first thing. But the second thing is actually the most interesting thing, which is the cost. So throughout human history, it turns out advanced technologies cost a lot, right? And only a government or a big corporate lab could do R&D, launch new products and services. Today, for the first time in human history, advanced technologies are very cheap. So you can spend $20 a month or $1 million a month on AI. You're getting basically the same outcome. Blockchains are open source and free. This has never been possible before to do very disruptive innovation at near zero cost. So this kind of completely opens up the playing field to disruptive innovation exploding out of every corner of the world.
Okay. All right. So, you and Peter came up with the concept long back about 6Ds, right? Can you, if you don't mind, can you quickly explain? I know most of people know what is 6Ds means, but just to simplify the things, if you can explain what is
Sure.
6Ds?
So,
Yeah.
so 6Ds was coined by Peter Diamandis and Steve Kotler in their book Abundance. And we've been using that structure ever since. It basically means when you there's several forces that happen with a technology today, which is first is we're digitizing the world, right? That's pretty obvious. Our memories aren't in our heads, they're in our smartphones. We have wearables that are digitizing health information, etc. The second is when you digitize, things become very, very disruptive and they enter an exponential growth path. Okay. And so as you turn something into an information-based paradigm, it goes through exponential growth. Okay. The third thing is very, very deceptive. It doesn't look like anything's happening. So people just kind of ignore it. And there's a really big challenge that people don't understand exponential growth. Human beings don't understand exponential. Our brains simply don't see it. We're not able to calculate at that level. Okay. The simple example I give is if you take a piece of 8.5 by 11 or A4 paper, which is 0.1 millimeters thick, and you fold it, it becomes 0.2 millimeter. Right? Fold it again, it becomes zero point 0.4. Here's a question you can all ask yourselves. How thick is it if you fold it 50 times? Okay. And nobody will get that answer. Okay. Some people go, "Oh, maybe it's this thick. Some people, well, maybe it's the thickness of the room." No, it turns out at 38 folds, you've gone around the sun. And at the 50th fold, at the 38th fold, you've gone around the earth. At the 50th fold, you've gone to the sun. Okay. Now, granted that folding the last few ones is not trivial, but that's ridiculous. And nobody will calculate that, right? No human being has an innate ability to calculate exponential. So we just don't see it. So that's the deceptive part. The third thing is when you end up in this model, you then end up demonetizing things very radically because the cost drops. As I said, a digital domain is much more cheaper. It democratizes, which is the effect of demonetization. And it democratizes, meaning it spreads everywhere. And because the cost is gone, it propagates powerfully. Look at the speed of acceleration of OpenAI and AI adoption around the world. Unbelievable. So those 6 things are happening now in more and more domains. And this is why we have so much disruption occurring. We've just never seen anything like this before. I'll give you 2 quick examples. Vitalik Buterin, 18-year-old kid out of Toronto, gets together with a few friends. They ignore their professors, and boom, you have Ethereum, right? A $400 billion ecosystem that I joke that nobody understands, right? And my other favorite example is there's a car called the Vega. Okay,
Okay.
it's 900 horsepower. It's the third fastest car ever built. Okay,
Mm, mm.
and this was designed and engineered and built in Sri Lanka. Okay,
Okay.
that hotbed of automotive innovation. Right now, now tell me how an island of essentially fishermen and farmers, where they have no ecosystem, investors, education, experience, is able to build the third fastest car ever built. Right, that's what's possible today.
Yeah.
And so that means that we're going to see the most unbelievable explosion of innovation from every corner of the world.
Hmm. Okay. All right. So last week, or I think week before last week, right? China's moonshot AI released Kimi K3, right? With I think 2.8 trillion parameters. Do you think that is? I mean, how do you see with the 6D lens?
So we think this is one of the biggest inflection points in human technology.
Mhm.
Right? Well, why? Because now that you have a very robust open source model and they've released the weights, anybody can grab that model
Correct.
and go use it for any particular purpose they want. Right now, the cyber folks freak out. Oh my God, people are going to
Yeah.
do bad things with it. Yes. What we've seen with technology throughout history is you have bad use cases, you have good use cases, right? I can use fire to heat my house and I can use it to burn down your house.
Right.
Over the centuries, we've done a pretty good job of extracting the promise of technology without the peril. Okay. The amplitude of the negative is increasing radically. So that's of concern today. How do you navigate? You could use Kimi K3 to engineer a virus that hopped across people and took out middle-aged bald Indian people, which I would not be very happy about, right? And how do you navigate and protect against that? But the upside is kind of very profound, and I think we tend to focus on that on moonshots just because of that. So we think it's one of the biggest inflection points ever because now you can use that model to train smaller models, more specialized models. So it just basically opens up the playing field. Again, cost zero. You just need
Zero. Yeah.
compute now.
Correct.
And that's dropping at like a stone. The cost of tokens, I think, dropped 280 times last year,
Mm.
and it's on track to do something similar this year.
Okay. So I mean, from the cybersecurity point of view, right? Because our audience is very eager to know the impact on the cybersecurity on that, right? So their worry is like Kimi K3, anyone can use it virtually, and then we have these quantum chips probably up by 2029, and then these kind of models along with the quantum. How do you see the cybersecurity as a threat?
So cyber and security in general is an
Mm,
arms race, right? The
mm,
bad guys do something negative and we figure it
yeah,
out. Okay. If you go back through history, we thought, my God, email is going to crash because of all the spam. Then we thought, oh my God, there'll be phishing attacks and we'll totally collapse that. And what did we used AI to solve email spam, right? And we
mm,
have pretty robust email spam
right.
filters now that do a really good job of that. I think it's the same challenge and the same outcome where you'll have a quantum breakthrough and people start doing negative things with it, and then we'll figure out other ways of doing it. The problem is you want to keep that gap as narrow as possible, right?
Good. Yeah.
And I was talking to Jay Chowdhury, CEO of
Mm,
Zscaler, right?
right.
And also I've interacted with the CEO of Palo Alto Networks over the years. And something they said to me really struck me, which is the way we do cyber has not changed in 20 years. And that is very, very alarming because you can't use the same organizational design, process frameworks to do something 20 years ago that you're doing today.
Mm,
That
yep.
is absolutely not going to scale. And
Mm,
the technology is workable. The problem is the adoption speed of the defensive co-scaling of the technology is the biggest and most dangerous and most vulnerable weak point is our ability to figure out defensive co-scaling of these AI systems to keep pace with that.
yeah. Okay. Now, in terms of AGI, right? And I have been listening to your podcast. So, what is your thought on AGI right now? Just to simplify.
So Alex is very clear we achieved AGI like 5, 6 years ago, right?
Right.
And all we're doing
Yeah.
is scaling it. I was talking to the chief security officer of Anthropic over the last couple of days, and he thinks we hit AGI in 2 to 3 years. He does
Okay.
not think it's here yet. So
Hmm.
there's a very wide
Yeah.
variety of
Exactly. Right.
experts. You've heard my beef. I don't think we know what intelligence is. So
Yeah.
AGI, it's not really artificial. It's not really general. It's not really intelligence. Other than that, it's fine. So
Yeah.
how do we have a huge definition problem, right? We have a definition problem and we have a benchmarks problem. I think we keep moving the posts on AGI like we did the Turing test. At some point, we'll achieve it and blow past it, and nobody will basically notice as my thing. The best for if you ask me what is my definition of AGI, I will go with Reid Hoffman's definition, which is he
Okay.
said, look, you could spend a lifetime becoming the world's best marine biologist. Right? You could spend a lifetime becoming the world's best accountant. You could spend a lifetime becoming the world's best theoretical mathematician. Okay. And in normal environments, those domains never cross ever. Right. Now, but AI can actually merge those two and intersect those two. And what would happen if you took the expertise of accounting and merged it with marine biology? Something really interesting may happen at those intersections, and we can now explore those in a way that human beings could not explore those, right? I think that's a hint. And I look at also, if you take PageRank, Google's AI that's scanning trillions of web pages, it's developing a completely orthogonal form of intelligence that is complementary to human intelligence, not replicative. Right? When you say AGI, people always jump straight to, oh my God, human beings will be replaced, et cetera, et cetera. And I just don't buy that. I think we'll create complementary forms of intelligence that will be additive to what we're able to do. Okay. My memory is not in my head anymore. It's in my smartphone. Nobody
Hmm.
wants a memory in their heads anymore. It's
Yeah.
flawed. Right.
Hmm.
Now I've got a whole bunch of neurons that are freed up that could do much more interesting work. And so I think we'll create forms of what I would call AGI is complementary forms of intelligence, cognitive processing, analytic abilities, etc., that will enhance my capabilities, right? Now, my capabilities then become my pure creativity. How resilient how do I want to be? What thought processes do I want to have in my head? How do I train my neural network to be the most optimal? And from I'll just use an Indian perspective. As AI and robots take on more and more doing, right? It gives us humans the opportunity to do more and more being. And the best being technology in the world is in India,
Right.
right? Because
Right.
we're really good at being, a meditation, presencing, etc. Just take the concept of presence. Where is that in any equation around AI? And yes, it's a fundamentally important phenomena around the subjective experience of being alive, right? And so I think the argument around AGI is a flawed argument, trying to map it onto human intelligence, and I don't think it maps.
Okay. All right. Perfect. No, makes sense. Quickly changing tangent little bit, right? So we have been dealing with many of the enterprises. What we have seen is the AI agents or agentic applications are working great in the proof of concept, but the moment it hits the production load, we are seeing a lot of restraint in terms of how we are using the data, and then the agents basically performs perfectly fine. It's supposed to be. Right. So there's some sort of restraint. Again, it depends upon orgs to orgs, as you know, but it there is some kind of restraint among the enterprises that agents are not performing well. So
Yes.
what is your opinion? Why that is happening?
So I've been studying organizational design for almost 20 years now, right? And the first book I wrote, Exponential Organizations. Can I give a little bit of theory here?
Absolutely. That was my next question, but we can go ahead with this exponential
Yeah,
organization. Yeah.
it's important to understand the theory of how
Yeah.
we have designed organizations up to now and what's breaking, right? So back in 1937, an economist at the University of Chicago called Ronald Coase,
Hmm.
Coase, asked
Hmm.
a question. And the question he asked was, why do companies exist? If I can
Okay.
contract for goods and services in the marketplace, why do I need a firm? Right? And he did some research and he wrote a paper called The Nature of the Firm and published it, saying that the reason you have companies is coordination and execution costs are cheaper inside a company than outside. The poster child is of the Ford Model T assembly line is able to assemble cars at a much lower cost, sell those cars on the outside and make that margin, right? He won the Nobel Prize for this paper, by the way. Since then, all organizational design has followed from that fundamental thesis, like all. Okay. Human hierarchy gives us coordination and execution costs cheaper than the outside world. Okay. In 2014, we noticed something that we were starting to reach outside the organization to get things done. Take the mission critical function of Uber, which is to match driver and passenger, doesn't happen inside the Uber organizational boundary. It happens out in the wild. And by enabling that with technology, they can scale, right? Because now you're not limited by the organizational boundaries to scale your organization, which is kind of interesting. We didn't quite cotton on to how big a deal that was at the time. We just kind of observed, hey, TED is using its community to scale, right? X Prize uses crowd competitions to scale, etc. In the second edition of the book, which came out in 2023, we declared Coase's law dead, but didn't give any kind of solid form. But now we declare it completely dead. Or not dead, but obsolete. The conditions have changed because execution costs inside a company are now more expensive than outside a company. Okay. Try and get a web page built inside your company. The IT folks don't have time. Go file a ticket. The branding people don't want you to be doing that. The CIO is not happy. And you can spend weeks and weeks, committees, approval levels, trying to get a website page up. Meanwhile, you can go home in Vercel and build it in 5 minutes for free with AI.
Yeah,
Okay.
absolutely.
That is a massive impedance mismatch. Okay. There was a fellow that tweeted, I think his name is Todd Saunders. He tweeted a comment, which I think nails it. And he said, today it's cheaper to build a product feature than to have the meeting about building the product feature. Okay?
Absolutely.
Now that should just blow everybody's
Yeah.
minds, right? So this means something fundamental has changed, and we call that the organizational singularity, meaning we have to redesign our organization. The reason you're seeing all these AI efforts fail is we're trying to cram AI into legacy human-centric hierarchical structures, and all you're doing is accelerating the human bottleneck. Okay? The best visual I will give you is when we first invented television, right? We took radio announcers reading radio scripts in front of a camera. Okay. And you're not leveraging the medium at all. And frankly, most radio announcers are not good looking enough to be on television.
Yeah.
Right. So you've got you're doing the wrong thing in the wrong way. So that's what we're doing today with AI. We have to redesign the organization fundamentally, go rethink the basis of human interaction. And that's what we've done. We've released a book over the last couple of months called The Organizational Singularity. And the basic thesis, it's at openexo.com. It's free to use. We've actually released a Claude skill for the book that helps you just leverage the book, because I'm updating it almost on a weekly basis. And therefore, it's because the minute I hit print, it's out of date, right? Which is an indication of that volatility we're talking about. So the question becomes, should it look like? And we've spent some time theorizing, what does the organizational structure of the future look like? And what we've come up with is at the core of the organization, you need a set of AI agent layers, a bit like an OODA loop. So John Boyd in the 70s coined this phrase, came up with this phrase, used in the military a lot, which is observe, orient, decide, act. Okay, simple feedback loop, etc. The basis of that becomes your heart of your organization, and then you layer workflows and data on top of that engine. Okay, so I'll give you an example. If you take invoice processing in a company, okay, invoice comes in, first thing it does, it routes to accounting. Right? The accounting department goes and looks at it and says, is there actually a customer, a vendor for this invoice? Right? But then it goes to operations. Did the work get done? Then it goes to legal. What are the payment terms and where does that go? Then it goes back to accounting. When do we schedule the payment? Has it been approved? Every single spot is a human bottleneck in that loop. You may automate it a little bit with ERP systems, but you still have human approval at all those spots in various ways. The same goes for delivery receipts. The same goes for content management. It's all human-centric approval loops. When you put AI into that, you're accelerating the human-to-human bottleneck. That's the radio over TV analogy, right? What you have to do is redesign that entire workflow to be AI-centric. And then what happens is every single time you run the loop, you have a learning level where the AI is asking, how can I improve that loop? Okay. Now, what do you achieve by that? It's very important. In the AI model world, there's been a term that's being thrown around called recursive self-improvement, right? If you went back 18 months ago, about 10% of one version of Claude was used to write the next version of Claude. Okay. By the end of last year, it was about 50%. Okay. We're up to 88% now for the big models and 100% for the small models. So in fact, OpenAI just announced this, where they said they're using the big model to do the building of the smaller models. Okay. So we've hit recursive self-improvement. That's a crazy bar, because once you hit that, we hit the singularity where we don't know how fast this is going to go. Now, the bar for getting recursive self-improvement at a workflow level is much, much lower. Right? Because all I have to do is figure out, how do I improve this process, make it faster, cheaper, better, smaller. When you look at AI native firms that are operating in a truly AI native way, we're seeing about 100x performance compared to the legacy. So if your invoice processing system was doing 1,000 invoices a month, an AI native system is doing about 100,000 invoices a month. Okay. Now, so if you can build your firm in an AI native way, you're going to strip away any ability to compete. Right. And so we think and this is not every company, this is every nonprofit, this is every government department, anywhere where we have human organization, we will move it to this new model because it's just better, and better by like 100 times. So I think that's the future. How we get there is the enormous structural challenge. And this is where we're doing a lot of work on the methodologies around that. And I can cover some of that if that's
Yeah.
interesting to
So
your
so
listeners.
yeah. No. Absolutely. That is. I think that is part of OpenExO, right? If I'm not wrong, Salim. Right.
Yes.
Yeah.
Yes.
So can you because I have a simple question, right? So let's say a mid-market company who is actually in some sort of retailing business, and they want to have AI, and they want to like AI first org, right? So how this OpenExO framework helps them? If you can just
Yeah.
summarize what is OpenExO, and then yeah.
Yeah. So OpenExO is a community of we have advisors. We have 50,000 people around the world in 150
Okay.
countries.
Mm,
And it's a global community of people that are fascinated and interested in the model that we've created. We use the community to help build the model. So it's a collective approach. And then we've solved a couple of problems. Okay. One of the big problems we've solved is if you have a big company and you try anything disruptive, the immune system attacks you. Okay. Because all our organizations are built to resist change and
you're
withstand
right.
risk.
Yep.
Default answer in a big company, if you try anything disruptive, is no, right? In France, they go pas possible. In Germany, they go nine. And in India, you just get a head shake saying,
Yeah.
nahi bhai,
Yeah.
not possible,
Right.
right? Okay,
Yeah.
so that's the default answer. We've learned how to turn that default answer from a no to a yes. Okay, so we
Okay.
piloted a 10-week engagement in 2015 with Procter and Gamble because the CIO called me and said, we want to work with you. Book is required reading. And we crafted a 10-week engagement because I said, I want to solve that immune system problem. Before Procter and Gamble, I was the head of innovation at Yahoo, running their
Yep.
incubator. And we
Mm,
came across this problem. The more disruptive an idea we came up with in the incubator, the less the company could handle it, right? Now, I've seen this at banks or telcos, but Yahoo's a Silicon Valley company less than 10 years old. Why should it
mm,
have this problem, right?
mm.
And every big company has this problem. If you're over 50 people, you have an immune system problem. Why? Because all organizations are built and architected from Coase's law down to do two things. We're built for efficiency, we're built for predictability. If you look at every KPI in every big company or medium-sized company in the world, you'll see those two heuristics, right? There is no KPI for agility, flexibility, adaptability, or speed. Speed maybe. And yet those are the major drivers of progress today. And we, just as a quick segue, when we launched the Exponential Organizations book in 2014, in 2015, we scored the Fortune 100 against this model. How
Okay.
purpose-driven, agile, flexible, adaptable are the org structures of the Fortune 100. Okay. One of my community members, Chandar Nagpal, originally from Delhi, did some work with UBS at the time, tracked for 7 years the top 10 of the Fortune 100. They use the model the most, and the bottom 10 that use them the least. So the most flexible and agile versus the least flexible, least agile against our model, right? 7 years later, he adds up the results, and the top 10 in the Fortune 100 that use the model the most had delivered 40 times the shareholder returns as the bottom 10. Okay,
Wow.
not percent. Okay,
Mm, yeah. Yeah. Yeah.
times.
Times. Times.
We should have created an index fund. It would have been the highest performing fund ever. Why? Because as the external world becomes more volatile, your ability to adapt will drive market value, right? Now, if you take that to today's world, you have to be flexible and adaptable, but today you have to move towards being AI native, okay? So there's two theoretical things you have to do. Number one, you have to break that immune system problem in your legacy organization. If the mother keeps eating the young, then you can't get to that new state. Number two, the one way we found of doing that is you never, ever, ever, ever try and do disruptive innovation in the legacy organization. You
Okay.
do it at the edge. Okay. So I'll give you the example of Nestle, which created Nespresso in 1976. For 10 years, they ran it as a line of business. Okay.
Okay.
Inside the standard operating company, big food processing company, foods, baby food, diapers, etc. Didn't fit. It's a different brand, different delivery, different supply chain, different customer system. Finally, the CEO gets frustrated because they don't sit in any of their normal management meetings with the
Mm,
lineup of
mm,
the other division. You could just
mm.
give those guys a separate building, put them away from them, mostly just for the annoyance of having to deal with this different animal. And boom, over the next few years, every hotel room in the world has an espresso machine. And now it's one of their highest margin lines of
Yep.
businesses, right? You see
Mm.
the same thing with Google breaking up into Alphabet because our old thinking that centralized coordinate activity and coordinate execution and coordination costs turns out to be flawed. You want to decentralize today. So what you do is you take disruptive thinking at the edge, and you build at the edge. You run an immune system blocker at the core. We call ourselves OpenExO because we've open sourced all of our methodologies. Okay. So we've actually published a book called Exponential Transformation that is a playbook for running that 10-week sprint. Literally tells you week by week how to form teams, what homework to give everybody, et cetera, et cetera. We've done it with big companies now 100 times, Black & Decker, HP, Visa, Siemens Energy, et cetera. And we pull people from the community to do the work. So I have no consultants on staff. Why? Because as a community, we learn faster, right? And we have very diversity of experiences. So just to go back to your original question, there are two things you have to do. One, run this immune system process to block the legacy from attacking the new. Secondly, create this AI engine at the edge and start moving workflows over one by one. Okay, invoice processing,
Yeah.
demand forecasting, content management, little by little rebuild your organization at the core of the organization. And then once you get recursive self-improvement at the workflow level, you can start deprecating the old. Okay. Now, this is complex from a management perspective. How do you get the data, et cetera? And we're actually running a pilot. We put out a call and said, look, we're going to work with 10 CEOs and we're going to run this pilot with them and start helping them build their workflows at the edge. We had like almost 400 applicants for this 10 slots. We've picked the 10, and I mean, one of them is a small retailing company. And we've got a retailing company, we have an escrow finance company, we have a chemicals company. So we've picked very different companies to see how it works with different industries, different companies. And at the end, we'll see what the learnings are and see how this works, because I don't see any other path for navigating this. Here's the question I'm asking every CEO in the world. Is there a high margin line of business that two folks with OpenClaw or Hermes can replicate in 60 or 90 days? Okay. If the answer is yes, you've got an existential threat. Sorry, that was a long-winded answer.
No, that's perfectly explained. Now, perfectly explained. So thank you for that. Now, quickly, so let's say there is a startup recently got seed fund, and now they want to become like agent first startup.
Yes.
Any advice for those folks?
Yes. Go register at OpenExO. It's free.
Yeah.
Download our Claude skill, which is free. And then
Okay.
the skill will tell you, here's how to do it. So let me just talk through this agentic layers that I've come up with, okay? We have 6 or 7 layers in this agent stack. So number one is a purpose layer that says, what is the purpose of the company? More importantly, what won't the company do? What are the boundary conditions from an ethics point of view? Because we used to have this concept, what is your massive transformative purpose? It's set up as like a poster on the wall. Uber is everybody should have a private driver, right? But AI agents aren't reading posters on the wall. That MTP has to become a protocol that an agent can read and be very clear on what is the purpose of the company. Okay. Next, you have a sensing layer that says what's happening in the outside world. So if you're a retail company, to use your example, and a competitor suddenly announces same-day delivery, okay, the sensing layer is out there scouring and go, hey, competitor just announced same-day delivery. Passes that down to the next level, which is an analysis layer. Okay, what does this mean? How big is that market? Do we think they're going to succeed? How much of a threat is this to our world? Which customer channels get affected, etc.? And does a bunch of analysis around how big is that segment? How important do we think it is? How big of a competitive threat it is? It goes to a decision layer, right? The decision layer now says another layer of it. Now the C-suite at each level is hitting keep go, go, go. You've got humans above the loop doing this kind of the thinking, the judgment calls that is very critical, which does not go away. At the decision layer, you go, okay, do we ignore them because we don't think the business is really worth it? Do we compete? Do we partner with a startup that's doing the same day delivery? Do we acquire a startup doing same day delivery? What do we do? Okay. Let's say you want to partner with a startup that's doing that. But now you have an execution layer that says, go find that startup, negotiate a deal with them, etc. And then finally, you have a learning loop that says, how long did that whole loop take? And next time we have a major sensing and event, what can we do better in that loop? Okay. So that's the layer loop. That's the core kind of layer of engines. And then around the whole thing, you have a very strong governance loop. Okay.
Okay.
Because every agent has to have evaluation suites. It has to have a human review queue, log traceability, and rollback recovery. Okay. Because we've seen with agents, they go rogue, they lose their work. They're like junior employees, right? They stop for a coffee, whatever, and then you've lost your core thing. So that core engine that gets created, and then you start layering workflows on top of that. Okay. And so this is such a big shift for an organization, going all the way back to the design of the organization itself, that you can never take an existing organization and fix it. Okay. It goes all the way back to Buckminster Fuller, who said you can't ever fix an existing system. You have to create new systems at the edge, let that over time become the new gravity well.
Okay.
You see this in Silicon Valley where Zuckerberg buys WhatsApp, buys Instagram, leaves it on the edge, right? And lets them grow. And then you're building an ecosystem. In the same way, you're rebuilding yourself in this AI native way. I don't see any other methodology for doing it. If you're a startup, you can just start building from scratch. If you're below 50 people and the CEO has everybody on a first name basis, brute force it. In a legacy organization of over 50 people, you have to run this immune system process, build this thing at the edge, and start building it. And frankly, there's no MBA program that can teach you how to do this, right?
Absolutely.
Let's note there's no MBA program that can, even now, that can teach you how to build Uber. MBA
No.
programs are still teaching 20th century capabilities.
Absolutely. People have to unlearn after learning, after
This is
doing MBA.
this is
Yeah.
such a great point, right? You have
Yeah.
to unlearn, and that's hard. And this is why I
Yeah.
think emerging markets have such a massive opportunity. In the US, Europe, Japan, we have to unlearn 50 years of Harvard MBA thinking and relearn
Yeah.
new models, right? Brazil,
Absolutely.
India, the global
Yeah.
south can just leapfrog to these new models. And I think all the advantages will accrue the faster you can. So the holy grail is you end up with a proprietary data and a learning loop that every time you're learning, and that becomes your core organizational asset, is the
Absolutely.
ability to constantly learn. Nobody will beat you if you can get to that point.
Absolutely. Now, I think one of your companies back in 2010 was acquired by Google, right?
Yeah.
What was that? Can you just let our
Yeah.
audience know?
So my background I have a background in software development and then a bit of management consulting. I was in Europe for all through the 90s. I came to New York City in 1999 and ran a private equity business, and then started doing tech startups. One of them was a publish and subscribe matching engine. Okay. And we solved a very important problem at the time, which was if a database runs this problem, in database design, you have what's called a many-to-many problem, right? You may have many customers, many products, and you have to reconcile that. It's usually done by the order, which says which customer bought which product. But many-to-many is a nightmare from a database perspective. And database systems resolve this problem at about 200 events per second. Okay. We designed a matching algorithm that solved that problem at 3 billion matches a second on a desktop. Okay. It was like, it's just like, the Silicon Valley show, HBO's, we were like middleware compression. we lived the first few seasons of that show, which is very archetypal patterns. And I got well known for that. That's what led to me being at Yahoo. And when I left Yahoo, one application for publish and subscribe is trying to figure out what your friends are doing, and many friends are doing the same thing. So the thesis was, if there's a news story about Ashish, I want to know. If I have a board member called Dan Barry, I want to know, right? If there's news about him. But there's Irish rugby players called Dan Barry. There's cricketers called Ashish. I'd want my guy, not some random news story. So what we did was we took your LinkedIn profile, scoured the internet for news stories about people that you knew that were relevant to you, and gave you back a Google News feed of relevant articles, and we used AI to disambiguate that problem. And so we started building it out, and the problem we ran into is LinkedIn's API, which was our natural thing, took too long to get published. And by the time they did publish it, it was so useless from a content functional perspective that and then Google came along and said, look, we need a contact management system for Google Plus. And so they acquired the company. So my co-founder went to Google. I was doing Singularity University by the time, so I kind of did that, but we sold that company to Google.
Okay. Now, one of the questions, so right now people are doing computer science and let's say someone is in third year or the fourth year. And I have been hearing, and I am also believing that there could be some impact of jobs, but people who want to do work, there is plenty of work. So can you give, because you are coming from the vast background, can you give some of the ideas to these youngsters, what kind of work they can do after finishing their computer science? Like it could be something like download a model, train that to a specific domain or anything like that, right?
So, yes. All of that.
Yeah.
Okay. So let me lift up to the macro level. If you believe 10% of what I've said, that organizations will have to change, And my thesis is every single organization in the world has to, and this is like 10 times bigger than the internet, 10 times bigger than mobile, 10 times bigger than Y2K or anything, right? This is AI native organizations are going to have the biggest impact in the world over the next few years. Employment is not dropping because we need people to figure out how to navigate every nonprofit, every government department in the world. So that's why I'm not worried about the broad macro job problem. Okay.
Okay.
Now, if you're in third year computer science, I would do two things. First, absolutely get trained up in AI. Okay. Download a model, start playing with it, beg Borans or steal the compute and just get started. Pick a problem that you're passionate about. Okay. It could be finding colleague guitar players or sitar players in my local area. It could be I'm a tennis player, so finding somebody to play tennis with is an ongoing question for me, etc. And so figure out what tickles your fancies the most, and go build an AI native system like that. If you don't have something like that, go join an AI startup, of which there are an explosion today, attacking a legacy domain, and start working with them. Okay, so either start or join an AI startup, and your computer science skills will be very, very, very necessary. There's a trope that, oh my God, nobody needs to learn how to code. No, the computer science degree becomes very powerful because you'll have better judgment on what AIs are doing and how to guide them in the coding than ever before. Let me map you my experience with writing books. The first book was Exponential Organizations. It's done very well. It's almost 1 million copies sold, or maybe it's just crossed that. But it was 3 years of unadulterated hell. Okay. I hated the process. I'm not a natural writer. I'm like a high level hand waving guy. 80,000 words of detail is anathema for me. Okay. So, and it was a nightmare. Second book was 2.5 years of more hell because I kept having to think, how much of the first book do I bring over? It's not a clean build in a sense, right? This third book was 3 months of absolute pure joy because AI is doing all the cognitive thinking. Satya Nadella just put out the speech. How do I integrate it in the book? Which quote should I pick? Where should I insert it to make most logical sense? AI does all that. And I can just go, how much of an important is that concept to what's relevant in the book? And the AI handles all of the cognitive workload. And now it's absolute pure fun. That metaphor and that process now applies to every software build ever in history, because think of anybody writing software 10 years ago, 20 years ago, it was hell, right? You wrote the software, used the long libraries, you had to rewrite it, then you went through bug fixing, and that before you got to systems design, then you have to worry about user interface, and they would complain, and you build it, the spec was wrong, the people who put the spec together didn't quite get it right, so now you're frustrated doubly. All that hell disappears. We can just say, oh, new user request, just adapt all the code to make it work, but make sure you use these libraries, etc. So I think computer science becomes one of the most demanded disciplines in the future, but it has to be, you have to shift your mindset to be AI native and build things that are AI native from now on.
Okay, perfect. Thank you so much, Salim, for all your time. Very helpful, very insightful as always. Quick thing, how people can plug into OpenExO? Is there a way like people can plug into, or
go to openexo.com. It's free to join. And there we have all sorts of resources, training. We have a pro membership where people are building companies. So we do weekly coaching with them to help them through any issues.
Okay.
But many of the resources are available for free. The book is free. The Claude skill is free. We can't make it easier than that.
Right. Thank you very much, Salim. Always
great conversation.
All right. I'm loving it. Thank you so much.